Welcome to EDU World Space.
So in this problem, we have an ant which is at a distance of 0.125 meters from the lens, and the lens has the power of 8.00 diopters, and the height of the ant is 1 millimeter. So first, let's find the image distance. So our ant is the object, and it's obviously a real object, and the object distance is 0.125 meters. So we simply use the formula 1 by object distance plus 1 by image distance is 1 by the focal length. Now we know that 1 by f, the inverse of the focal length, is power p. So now in this equation, we simply need to find di, the image distance. So rearranging, we can see that 1 by di is equal to p minus 1 by d0, do. Now taking the least common multiple, multiplying and dividing p by do, we can write it as do times p by do minus 1 by do, which is p times do minus 1 by do. Therefore, the image distance is simply the inverse of this expression, which is do by p do minus 1. Now we know that object distance is simply 0.125 meters divided by power is 8 diopters, 8.00, and we know that diopter is the inverse of meter, times do is again 0.125 meters, minus 1. Also notice that the power of the lens is negative, which is minus 8 diopters. So we have another minus sign here. Now, if you notice that 0.125 is simply 1 by 8, you can see that this is 0.125 meters divided by minus 2, which is minus 6.25 centimeters. 0.125 by 2 is 0.0625, which becomes 6.25 centimeters. Now, notice that this image distance is negative. It's because the image is a virtual image which forms behind our real object. So you'll see we'll see that the ant is over here, but at a larger size, and this distance will be 6.25 centimeters, which is half of 0.125 meters. Now to find the height of the image, we simply use the formula for magnification. We know that magnification is height of image divided by height of object, which is the same as minus distance of image by object distance. So using this, we know that image height is simply minus di by do times the height of the object. So that is minus the image distance is minus 6.25 centimeters divided by the object distance is 12.5 centimeters times, we know that the height of the ant is 1.00 millimeters, which gives us half a millimeter. And notice that it is positive, which is because the image is upright. If the height were negative, the image would be inverse. Hence, our image is virtual because the light rays that are coming from the ant actually don't ever coincide, but they just seem like they coincide behind the lens. And the image is behind the lens. That's the reason for it being virtual, and the image is upright. That's the